At 9:30 p.m., the lake's surface began to churn. By morning, every living thing within 25 kilometers was dead. 1,746 people had suffocated in their sleep, killed by an invisible substance without warning. Across our planet, only a few lakes have demonstrated the terrifying power to cause death, silently, suddenly, and without warning. Lake Nyos in Cameroon, Lake Manoon, also in Cameroon, Lake Kivu straddling Rwanda and the Democratic Republic of Congo, and Laguna Caliente in Costa Rica. Their stories trace back to the same invisible threat, with volcanic activity deep underground, slowly charging these waters with an invisible killer called carbon dioxide, a gas that kills without sound, without smell, without warning. But for Laguna Caliente, its extreme acidity and toxic fumes makes this lake one of the most hostile places on Earth. Carbon dioxide, CO2 for short, is a colorless, odorless gas that can't be seen, smelled, or tasted. It's the same gas that makes soda fizzy and what we exhale with every breath. But under certain conditions, it can become dangerous. CO2 is heavier than air, so when large amounts are released, the gas flows like an invisible current, settling in low-lying areas and valleys. In high concentrations, it can prevent the blood from carrying oxygen to the body's organs. People exposed to these high levels may feel sleepy, confused, or disoriented before losing consciousness. Because CO2 is undetectable, victims often have no pain, no struggle, no warning. They simply fall asleep and never wake up. Lake Nyos sits in the crater of an ancient volcano in Cameroon's northwest province. For generations, local communities had lived peacefully around this deep blue lake, using its waters for fishing and daily life. But 300 feet below the surface, something deadly had been accumulating for decades. Carbon dioxide from volcanic vents in the crater floor was dissolving into the lake's deep waters under immense pressure. Year after year, the concentration grew. On the evening of August 21, 1986, something triggered a catastrophic release. The exact cause remains unknown, perhaps a landslide, an earthquake, or simply the gas reaching critical saturation. Scientists estimate that between 1.2 and 1.6 million metric tons of carbon dioxide were released in a matter of hours. What happened next was unprecedented in recorded history. The lake erupted like a massive soda bottle being opened. A fountain of water and gas shot nearly 300 feet into the air, releasing this vast cloud of gas. The gas cloud that formed was invisible, odorless, and heavier than air. This deadly cloud flowed down the valleys at speeds reaching 30 miles per hour. In the village of Nyos, people died in their sleep. In Cam village, families collapsed where they sat. In Subum, an entire community fell silent. The few survivors described waking up hours later to an eerie quietness. Cattle lay in perfect rows where they'd fallen. Birds had dropped from the sky. Even insects were gone. The landscape looked normal, but everything that breathed was dead. When rescue teams arrived, they found over 1,700 people and 3,000 livestock had suffocated. The survivors, fewer than 850 people, were evacuated and relocated. Many suffered long-term health effects from carbon dioxide poisoning. Some survivors also reported the smell of gunpowder or rotten eggs, suggesting trace amounts of sulfur dioxide or hydrogen sulfide. But carbon dioxide was the main killer. Degassing systems, installed by French and Japanese engineers, have been slowly releasing CO2 from the lake's depths since the early 2000s. However, as the volcanic source continues to supply gas, ongoing monitoring remains essential. But Lake Nyos wasn't the first time this phenomenon had struck. Two years before Lake Nyos made international headlines, another crater lake in Cameroon had already demonstrated this deadly capability. Lake Manoon, smaller and more remote, killed 37 people on August 15, 1984. The event followed the same pattern. a sudden release of carbon dioxide that suffocated everyone in the gas cloud's path. But with fewer victims and limited media coverage, the world paid little attention to this remote tragedy. Local authorities initially blamed the deaths on a truck carrying toxic chemicals. Some suggested volcanic gases, but no one understood the mechanism. It wasn't until Lake Nyos erupted that scientists realized they were looking at the same phenomenon. When researchers finally studied Lake Monoon's underwater topography, they discovered the source: depressions on the lake floor, where gas-rich water bubbled up from deep volcanic sources. The exact trigger for the 1984 eruption is still debated. It may have been a landslide, rising gas bubbles, or a spontaneous release. These underwater vents had been slowly charging the lake with carbon dioxide for years. The tragedy at Lake Monoon was science's first glimpse of limnic eruptions, lakes that could literally explode with dissolved gas. Recent research suggests that Lake Monoon may have experienced earlier limnic eruptions, as indicated by sediment deposits near these depressions. Today, Lake Monoon also has degassing systems, but researchers estimate there could be other similar lakes around the world, still unknown, still accumulating deadly gas in their depths. But when scientists began mapping this global threat, they discovered something far more terrifying. Lake Kivu stretches across 2,700 square kilometers between Rwanda and the Democratic Republic of Congo. It's one of Africa's Great Lakes, supporting fishing communities and major cities along its shores. Over 2 million people live within the potential danger zone. Unlike the smaller crater lakes, Kivu contains not just carbon dioxide, but massive amounts of methane, an estimated 60 billion cubic meters of dissolved gas. That's enough natural gas to power a small country for decades, all trapped under pressure in the lake's depths. Scientists estimate that Lake Kivu holds 300 times more dissolved gas than Lake Nyos did before its deadly limnic eruption. If a similar event were to occur here, the consequences could be catastrophic. The evidence is written in the lake's sediment layers. Core samples reveal geological markers of past gas releases, massive eruptions that occurred thousands of years ago, long before human settlements existed around the lake. But Lake Kivu's story has taken an innovative turn. Engineers have built extraction plants that harvest methane for electricity generation, with new projects continuing to expand capacity. These facilities slowly reduce gas pressure while providing clean energy to local communities, turning a deadly threat into a valuable resource. Despite past concerns about rising gas levels, recent scientific studies show that methane and carbon dioxide concentrations in Lake Kivu are currently close to a steady state, thanks to ongoing monitoring and gas extraction. Lake Kivu remains what scientists call the most dangerous lake on Earth, a sleeping giant that could awaken at any time. But the phenomenon of deadly lakes is not confined to Africa or to gas eruptions. In Costa Rica, Laguna Caliente stands as one of the most hostile environments on Earth, shaped by volcanic activity, yet deadly in a completely different way. At approximately 7,500 feet, 2,300 meters above sea level, in the crater of Costa Rica's Poás volcano, sits Laguna Caliente, one of the world's most acidic natural bodies of water. This turquoise lake glows with an otherworldly beauty that attracts thousands of tourists each year. But this water is more acidic than battery acid, with pH values often near or even below zero, and temperatures that can reach the boiling point, sometimes exceeding 90 degrees Celsius, 194 degrees Fahrenheit. The lake constantly emits toxic gases that create acid rain and fog in the immediate area, decimating surrounding vegetation and causing severe respiratory problems. Laguna Caliente contains sulfuric acid, hydrochloric acid, toxic metals, and dozens of other volcanic compounds, a combination that could cause most scientific equipment to dissolve or corrode within hours of submersion. Any organism, such as animals or plants, that come into contact with this water would die within minutes. Remarkably, however, certain extremophil bacteria, like Acidophilium, have adapted to survive these harsh conditions, metabolizing sulfur compounds and storing energy as bioplastics. Despite the danger, Poas National Park allows controlled visits to a viewing platform at the crater rim. The platform is positioned at a safe distance from the lake, protecting visitors from toxic gases and acid water. Park authorities continuously monitor gas levels and wind conditions, closing access when toxic plumes or harmful clouds of dangerous volcanic gases threaten visitor safety. In 2017, increased volcanic activity forced the park to close for over a year. When it reopened, new safety protocols limited visits to 20 minutes, long enough to witness the lake's alien beauty, short enough to minimize exposure to its deadly atmosphere. It's an active volcanic feature that will remain dangerous as long as the magma chamber beneath it stays active. Four lakes. 4 different ways that water can turn deadly, whether by suffocating gas, explosive methane, or corrosive acid, each shaped by the raw power of Earth's volcanic activity. Lake Nyos, Lake Monoon, Lake Kivu, and Laguna Caliente aren't just bodies of water. They're reminders that our planet's most beautiful places can harbor its deadliest secrets. But these lakes also demonstrate human resilience and ingenuity. Scientists now monitor gas levels in real time. Engineers have turned deadly methane into clean energy. Warning systems protect visitors from invisible dangers. In nature, the greatest threats often lurk silently, unnoticed, unpredictable, and deadly.